All right, so we're on YouTube live now. Here, we're going to transfer this link over to our colleagues at with our Facebook site. All right, so we're on YouTube live now. Here, we're going to transfer this link over to our colleagues at with our Facebook site. All right, so we're on YouTube live now. Here, we're going to transfer this link over to our colleagues at with our Facebook site. All right, so we're on YouTube live now. Here, we're going to transfer this link over to our colleagues at. We're going to have some feedback here. Everybody's got to just pay attention to just for a minute. Live now. Here, we're going to transfer this over. All right. Okay, I'm guessing we were going to start at 7:07. And we are live here. If you're just joining us, we are dealing with just a couple of technical issues, and we will be with everyone very, very shortly. We'll give everyone on our Facebook feed a chance to come over here to YouTube. This is what happens sometimes when Facebook is updating their system, and it creates a little bit of connection havoc. So, as you see, I'm joined with by Megan Arrighetti this evening, and who we'll talk about her just a little bit later. I'm sure she knows a thing or two about troubleshooting. So we will we'll let everybody get over here. Promised in about 1 minute we will formally get underway with this evening's show. All right, we've got our go from our technical man on the scene, Jim, who is fortunately back with us this week after a couple of weeks of camping out in the middle of the country, I understand. And he will be responsible for getting any feedback to me this evening and any questions for myself or our guest. And we'll go ahead and get started formally here. Thank you for your patience, and welcome to the October 2nd, 2020 edition of Fernbank Science Center's At Home Planetarium show. My name is Scott Harris. I'm the staff planetary geologist for Fernbank Science Center and the Jim Cherry Memorial Planetarium in Atlanta, Georgia. And so we are joined this evening by a special guest, Megan Arrighetti, who is a graduate student in physics at the Georgia Institute of Technology, or Georgia Tech, or as us dogs call it, the North Avenue's Trade School. We have to give them a little bit of grief, but fortunately, Megan is a dog. She did her undergraduate work at the University of Georgia, and doing something really cool and special that is part of the reason she's here this evening. You may know that last night we had an aborted launch of an Antares rocket from the Wallops flight facility up in Virginia that was to carry the Cygnus spacecraft up to the space station, and on board was a small satellite, a CubeSat, that was designed, developed, built, and run by the University of Georgia's Small Satellite Research Lab. And if I understand correctly, Megan spent some time as the operations director for that the mission of that satellite. And it is now scheduled to launch this evening at about 9:16 Eastern Daylight Savings Time. And And so I asked her to be with us for a couple of reasons. One, to talk a little bit about that mission, and hopefully at the end of tonight's program, we will cut away to NASA coverage of the launch. Again, there'll be have some time in there. You'll have some NASA TV to watch. I may throw in some commentary. I don't know how long Megan can stay with us, but we're going to learn a lot about that mission from her this evening. But she is also has her degree in astrophysics. So she is, I'm sure, continuing research with that at Georgia Tech, and so she seemed like an excellent person for to help me answer any questions you have about the universe, which is the topic for tonight. We're going to our feature presentation is the Hot and Energetic Universe, a production that's provided courtesy of the European Southern Observatory. And we'll look forward to that. And we'll be back with a few intro questions for Megan in just a moment. But as usual, we're going to cut away now for a brief look at our nighttime sky. So we will go over to our Stellarium program to do that this evening. And we'll bring up our evening sky here in approximately real time. It's about 10 minutes after 7 Eastern time. And as we're looking off to the west, we see that last glow of the sun disappearing into the fall evening. And we're going to look around just a moment and see if we see any bright things out there in the sky. We may need to go just a little bit deeper into the evening. I'm going to go ahead and advance just about an hour. So we'll be after sunset at about 8:10 this evening. And as we do that, and looking west, we are bound to see a very bright red object. That is the star Arcturus. That is a red giant star that is the brightest star in the constellation Boötes the Herdsman. If you have any doubt that you're looking at Arcturus, you can look around here to the northwest, and you can see these famous 7 stars that form the shape of a pan with a handle attached that we call the Big Dipper. The Big Dipper is an asterism. That's a fancy word for a shape made of stars, and it is part of the constellation Ursa Major, the Big Bear. It's actually the back and the tail of the bear. You know that if you take the 2 stars at the end of the Dipper here, at the end of the pan, you can shoot over to Polaris, the North Star. But in this field of view, we can do what my astronomer friends often talk about, is we take the arc of the handle of the Dipper and we arc right over to Arcturus. And if you see a herdsman here, I always say, congratulations, you're better than I am. I actually see a kite. Here we have a diamond, sort of an elongate diamond there in the sky. Imagine the tail leading down to the horizon with a little decoration there at the end. That would be Arcturus. If you have a hard time seeing those, that's why we have Planetarium software and Planetarium programs, so we can help you understand what those ancient astronomers of Greece and Rome and other ancient civilizations were seeing there in the sky. And so as we, I'm just going to move up high into the sky tonight, way overhead, just move up toward what we call the zenith. And we're going to find a couple of birds here, including Cygnus the Swan over here, the namesake of that mission that's flying the CubeSat tonight, the Cygnus 14, I believe it is. And we have the swan, we have an eagle, and over here we have this little musical instrument, a harp. If I take away the art, we're going to instead see a great triangle in the sky. This is what my astronomer friends call the summer triangle, composed of the bright stars Vega, Altair, and Deneb, the brightest stars in each one of those constellations. We have Vega in Lyra the harp, Altair in Aquila the eagle, and Deneb the tail feathers of Cygnus the swan. They form that summer triangle. That is another asterism, but this time not part of a constellation. Again, each bright star is in its own constellation. Now, if you watch the flight of the bird, here we have really you see a giant cross in the sky, right? Follow the end of that cross down, that's the neck of the swan. Follow the flight of the bird down to the south, and you are following along a milky river of stars that we, of course, call the Milky Way. And those are the the bands of our spiral galaxy that we are looking through. And in this direction tonight, we are looking directly into the tail of the Scorpion Scorpius. You might see the red star, the red giant star Antares over here to the southwest. If we look right at the tail, right in between the tail of Scorpius the Scorpion and the arrow of Sagittarius the Archer, it's right here. Right in this direction, we are looking directly in toward the center of our galaxy, where we have actually the light of hundreds of millions of densely packed stars shining in our direction through a lot of dust. And that's why things look so bright in that direction, even if we can't quite make out the bands of the Milky Way themselves in our light polluted skies. But get out to a dark sky and you can see that. Of course, we have Jupiter and Saturn here to view in our planetary neighbors. And tomorrow afternoon at our 1 o'clock Planetarium show, I will be featuring the moons of Saturn. As we move around to the east, we have our moon there, one day after full. They're rising above the horizon just at about 8:15. And close with it is Mars. And so I know a lot of people are eager to go out and look at those as they are very close to each other. Notice they do not appear to be the same size. I know sometimes when Mars is near opposition, meaning it's fairly close to our view, close to us, and we get a good view of it. We have these hoaxes that come out sometimes where it looks like there's the same size in the sky. That's never going to happen. But they are beautiful out there. And as we look at Mars, we can think about we can certainly think about those missions that are on their way to Mars right now, including Mars 2020 with the Perseverance rover set to land there in February. All right, so we're going to cut away now back to our guest. And again, thanks, Megan, for being with us this evening. And I'm just going to ask you a few questions before we get to our feature presentation. And again, if you are out there in our viewing audience, again, thank you for your patience coming over here to YouTube with us this evening. Megan is one of the participants and leaders in the SPOC mission, that is a small satellite being sent by the University of Georgia Small Satellite Research Lab up to the space station and then deployed from the space station to do some imaging of the Earth's oceans and coastal areas. And so I'm going to ask you to give us a little bit of a background about what you did with that. And then I'm going to ask you a few things about the, what sort of research interest you have and kind of how you got interested in all this stuff. So again, we welcome Megan Arrighetti. And again, just tell us a little bit about this mission that's going to go off hopefully about 9/16 tonight.
Yeah, so SPOC stands for Spectral Ocean Color. And I don't know because I joined the lab about a year after it was formed and a little while after they had come up with the mission. So I don't know if they chose the name Spock for Star Trek. I don't know, but
they had to.
So I know that if anyone watched the UGA program yesterday, you got to hear some of the founding members speak, and Paulus, who I worked a lot with in the lab, spoke to how there was a group of students and they wanted to build a satellite. And they kind of looked around, saw that no one at the university was doing it, and they somehow got in touch with some faculty in the geology building. And they said, hey, these are some things that we want to do. We want a satellite to do these things. And the students were like, well, we want to build a satellite. So they got together and came up with Spock and Mochi. And Spock is going to be acquiring images across multiple spectral bands. I think it's about 430 nanometers to about 860 to monitor specifically the Georgia coastline. They'll be monitoring other places and obviously hoping to get cool pictures of Earth, but the main goal is to monitor coastal wetlands and ocean productivity, stuff like that. Yeah, I think that covers what Spock does.
Well, like I said, we're looking forward to seeing the launch of the Cygnus craft on the Antares tonight, carrying Spock along with it. And my understanding is that it'll take about a month or so for them to really get that into position and deployed. I know you were telling me earlier that you're native Atlantan, and it's always and been to the Science Center, and so if you don't mind sharing with us, I mean, just how did you get interested in satellites and space, and kind of and I think you have your degree in physics and astrophysics. How did you get interested in that, and where do you plan to what do you plan to do with that?
Um, I I changed my mind a lot when I was growing up about what I wanted to do. I think as most kids do. But in high school, I was taking an AP art class and I was into photography. And I went to the North Georgia mountains and I took some photos of the night sky. And I was like, wow, this is really beautiful. Like, this is so cool. And I knew absolutely, and that was about all I knew about it, was that it was really pretty. Um, and then I think I watched Interstellar and I was so confused. I left that movie more confused than ever. And I started Googling and I was like, wait a minute, I can study these in a classroom. I don't just have to Google it, although I do use Google quite a bit. So that hasn't changed. But so yeah, I figured it was something that I would never be bored with. And so far I've been right. Um, it is certainly not boring. But yeah, I think it was just a testament to my curiosity, and there's so much that we don't know, and there's so much to learn. So that's kind of how I got started, how I decided that this is what I wanted to do. As far as what I would like to do in the future, once I get my PhD, I would like to do research and maybe even teach. I'm a TA now, and I actually really like it. I think it's really gratifying when I help a student understand a concept. So I think research, I think in astrophysics, but there's also a lot of really cool research at Georgia Tech that's not astrophysics, that's just other kinds of physics. So I'm trying to keep my options open and not box myself in, but
Well,
definitely research.
that's a good lesson to a lot of young scientists out there. So I'm glad you're doing that. But I think a lot of us who start off in doing research and teaching is always a part of that. Whether it's teaching students or educating the public in outreach activities, that's always part of the game. And so it's good you're getting exposure to that. I think it makes you a better scientist. But yeah, if you enjoy that, I hope that goes well for you. Now, we already have a couple questions here from audience just about the Spock mission, and I'll let you address those if you can. Somebody you mentioned that it's designed to measure the ocean productivity and looking at the Georgia coast. And I'll just read it as it was put to me. Says, can we explain ocean productivity? Is that a biological activity, and how can the satellite measure it?
So I do believe, I don't know much about this side of the mission. I think
Mhm.
I was more worried with just getting the data, but from my understanding, it's going to use, so we can choose which spectral bands that we want to downlink. So if we want to know about phytoplankton or other biology that's going on in the ocean, I believe we would probably downlink more greens and yellows. And so I think that's how it would be measured by folks in the geology department. Whoever is using this data would be to know what's going on using the different spectral bands, if that makes
Yeah,
sense.
I think that, yeah, that's right. I
Hopefully
mean,
that answered their question at least
yeah,
a
I
little
think
bit.
I think that does. I mean, that's the all these different organisms look different, and they interact with the light that is from the sun in different ways. And so when those spectrometers get a chance to look at that, you can see those different things. We actually teach that to our planetary science class that we do for ninth graders in our scientific tools and techniques program at Fernbank. So spectroscopy, spectrometry are incredibly important for understanding not only our own world, but those worlds out there beyond us. So as we get ready to start the our feature film tonight, I would just kind of ask you, have you, as you've spent time studying physics and astrophysics, is there a thing right now in your mind? I know you're a young researcher, but when you look at all the things that are out there, from black holes to quasars to all these things, is there a favorite? Is there something that just really that you think is the coolest, most crazy thing that's out there in the universe?
I don't know about the craziest or coolest, but certainly for me, the most exciting right now, and I think a lot of my peers would say the same thing, is gravitational waves. I remember sitting in class when that paper came out um, a couple years ago, and it was really exciting. And there's a lot of cool research that's going on with it because it is so new. So I think I'd have to go with that for now, but I'm sure that will change as time goes on.
All right. So we're going to go ahead here with our feature presentation of a hot and energetic universe, some of those things out there that are producing those gravitational waves. And I'm sure at the as we go here, if you do have any questions as it's going along, please do pass those along through Jim, and we'll get those over to Megan, and hopefully we'll see you on the other side here. So let's enjoy the hot and energetic universe.
The universe was always the final frontier of the human quest for knowledge. Through all its history, humanity has observed the sky trying to understand the cosmos outside the limits of our planet. Today, this effort has yielded significant results. Now we know that our sun is a typical star, which does not differ significantly from other stars of the starry sky. We have discovered the planets of our solar system, and we have studied the conditions prevailing in them. We studied asteroids and comets and found their important role in the formation of planets. We understand the basic principles of the formation, the life and the death of stars. We have also discovered thousands of exoplanets like our Earth, orbiting other stars. We studied giant star clusters. We have discovered dense clouds of interstellar dust and gas where new stars are born continuously. We have managed to describe the giant complex of stars to which we belong, our galaxy. we realize that our galaxy is not alone in the universe, and that there are hundreds of billions of galaxies. We discovered that the universe of galaxies is extremely violent and in constant motion. Finally, we found that the whole universe is an accelerating expansion, and we are searching urgently for its origin. This quest is an epic journey towards knowledge, which abolishes superstitions and defines human existence. Vehicles for the journey of humanity in the universe are scientific instruments called telescopes, which are installed at various observatories. Telescopes collect light. Their performance depends on the diameter of the lens or mirror used. Today, we have giant telescopes with mirror diameters up to 10 meters. Most of these telescopes are installed in remote areas of the Earth, away from cities, the artificial lighting of which prevents serious astronomical observations. European Southern Observatory is building a giant telescope with a diameter of 40 meters that will penetrate and study the universe across cosmic time. The most important step in the exploration of the universe is the use of orbital telescopes that observe the universe outside of the Earth's atmosphere, such as the Hubble Space Telescope. Light is much more than optical telescopes can record. Light consists of electromagnetic radiation at many different frequencies. Most of them are invisible by the human eye and the optical telescopes. There are radio waves, microwaves, infrared radiation, optical light, ultraviolet radiation, X-rays, and gamma rays. All these forms of light comprise the electromagnetic spectrum. The human eye can only see a small part of the electromagnetic spectrum that consists of the basic colors. Celestial bodies usually radiate at many wavelengths simultaneously. They emit more in some wavelengths than others depending on their temperatures. The hottest and most violent processes emit at small wavelengths, that is X-rays and gamma rays, while the cold and calm processes emit at large wavelengths, such as in the infrared and radio. Radio waves are observed with giant antennae, the radio telescopes, that have the ability to observe the whole sky 24 hours a day and in all weather. The vast majority of the electromagnetic radiation cannot penetrate the Earth's atmosphere, so we are using orbital observatories. Most notably, the high-energy ultraviolet X-rays and gamma rays cannot be observed from the Earth's surface. But X-rays and gamma rays allow us to observe the most violent and impressive phenomena of the universe. For example, the usual image of the night sky is completely different when observed at these wavelengths. The only way to observe the hot and violent universe at high energies is to use observatories in space. These observatories allow us to study physical processes invisible to the human eye. X-rays, or Roentgen radiation, are named after the German physicist Wilhelm Roentgen, who studied them in 1895. They have been used for many years now in medical diagnosis. Gamma rays are discovered from the French physicist Paul Villard in 1900 and are well known for the catastrophic effect they have on living creatures. In 1948, American scientists observed X-rays emitted from the sun using special detectors on German V-2 rockets. In 1962, a team of scientists under Riccardo Gianconi observed for the first time X-rays emitted outside the solar system, a source towards the constellation of Scorpio. The first successful record of gamma rays from space was done in 1961 from Explorer 11. The contribution of the first American space station, the Skylab, was also important. The station was launched in 1973 and for 6 years observed the sun at X-ray wavelengths. Since then, tens of orbiting observatories have been launched, observing with increasing sensitivity the universe in X-rays and gamma rays, providing us with a more detailed picture of the most violent processes in the universe. Today, one of the most successful observatories is the Chandra X-ray telescope that was launched on the 23rd of July 1999 from the Space Shuttle Columbia.
Continue switch to off. Super. And CDR, please. CDR, go ahead. Jump panel 07.
Chandra has the sharpest view of the X-ray universe.
Hands 1, 2.
Go ahead on 07.
Okay, hands 1, 2, and 3. All 3 mode switches to on.
Panel 07.
The XMM Newton satellite, which was named after the famous Isaac Newton, was put in orbit by employing the Ariane 5 rocket of the European Space Agency. Its main goals are the detection of X-ray emission from solar system objects, detailed studies of star-forming regions, investigation of the formation and evolution of galaxy clusters, the environment of supermassive black holes, and the mapping of the mysterious dark matter. New Star was launched in June of 2012, and its main mission is to observe supermassive black holes hidden by large amounts of dust and gas. The US Fermi mission and the European Integral mission detect the most energetic radiation that comes from space, gamma rays. With these observatories, we study celestial bodies like our sun to understand the mechanisms that create solar flares, as well as the high temperatures of its external atmosphere, named the corona. We observe the birth of new stars in regions where large molecular interstellar clouds exist. In these regions, small gravitational instabilities can cause the collapse of these clouds and give birth to the formation of new stars and planets. We also study the violent death of massive stars that take place during supernova explosions. After the explosion, the cores of stars with high masses end up in what we call black holes. From these stellar remnants, nothing can escape. Even light gets trapped, making these objects invisible. Their strong gravitational field distorts time and space around them. Black holes attract everything that goes near them, increasing their mass in this way. Matter, as it collapses onto black holes, creates an accretion disk around them. In this disk, the temperature and kinetic energy are so high that gamma rays and X-rays are generated. At the same time, strong gravitational fields create jets that move with a speed close to the speed of light and interact violently with the interstellar matter that surrounds them. The death of medium mass stars creates what we call neutron stars. These objects spin at very high velocities, and their radiation can be most easily observed when the beam of emission is pointing toward Earth. This creates periodical changes in their luminosities, and this is why we call them pulsars. Pulsars can also have accretion disks and jets, but their scales are smaller compared to black holes. We also observe binary stars that are very close together and interact strongly with each other. There are special cases where one of the binary stars is very dense, like a neutron star or a stellar mass black hole. In these cases, mass is transferred to the neutron star or stellar black hole from the accompanying star, which eventually results in the violent explosion of a supernova. We observe the results of the merging of two common stars or the more violent merging of two neutron stars. These mergers always end up in the brightest explosions known that produce X-rays and gamma rays, the gamma ray bursts. Gamma ray bursts are the most energetic events known in the universe. The Italian satellite Beppo Sachs played a crucial role in the identification and understanding of what gamma ray bursts are. The SWIFT mission is a dedicated mission to find and study gamma ray bursts. Less often, but at larger scales and more impressive, are the mergers of two black holes. These are the most violent phenomena in the universe and generate inconceivable amounts of an exotic form of energy, gravitational radiation. We also observe the center of our galaxy, where a black hole interacts with the surrounding matter. Studying the motion of nearby stars has revealed that the mass of the black hole is 4 million times the mass of our Sun. Observations from the Fermi telescope showed that there are two large lobes of gamma rays that expand out to 25,000 light years from the center of our galaxy. We study in detail galaxies that emit huge amounts of energy from their nuclei and are known as active galactic nuclei, radio galaxies, quasars, and blazars. These galaxies have massive black holes in their center, with masses 1,000,000 or even 1,000,000,000 times the mass of our Sun, and accrete huge amounts of matter and have jets that extend out into the intergalactic medium. We observe the interactions, collisions, and mergers of whole galaxies that play a crucial role in their evolution. Finally, we can observe the primordial universe, where the death of the first stars was much more violent, and the interaction and mergers of the galaxies was taking place more often. All these observations help us understand the evolution of our universe and the physical laws that govern it. The European Space Agency's Athena mission will be launched in 2028. It will revolutionize our knowledge of the high-energy universe, carrying the largest X-ray telescope ever constructed. Athena will observe the first black holes in the early universe and will understand how they interact and how they affect the evolution of their host galaxy. The universe seen in X-rays and gamma rays is an inhospitable and violent environment. We live under the safety of an atmosphere and reside on the spaceship we call Earth, without realizing all these amazing phenomena that take place next to us.
All right, we are back here with our special guest, Megan Arrighetti from Georgia Tech. And I hope you enjoyed the program this evening. And I'll just, if you, we've got time here. If you do have any questions about anything out there in the universe, you have a astrophysicist here with Megan to help answer any questions you have. So if you have those, please pass them along to Jim, either through Facebook or, quite frankly, even through YouTube, and we will be able to get those, and he will relay those over to us. Again, just kind of in looking at all of those different types of galactic and stellar phenomena that are out there. Just it's an incredible, literally an incredible universe of diversity and new things that we're learning all the time. And you were talking about the gravitational waves, and I mean, just as you think about those, I mean, do you have big questions about those yourself, or any kind of research angle that you're thinking about exploring with those?
I don't even think I know what my questions are. I think that's how little beyond the classroom, how little I know. I do know that there are a couple of professors at Georgia Tech who are doing really cool research. There's a professor working with LIGO, the Laser Interferometer Gravitational Wave Observatory. And she's one of the many people working with them and collecting data for LIGO. But I think just combining research of understanding black holes and how they interact and when they create gravitational waves, if, you know, that kind of thing. I think also it's a testament to how cool theory is. That theory predicted this long before it was ever observed. So all that hard math I do.
It's funny you just said that, because I was going to ask you that, because we at the Science Center, we deal with a lot of students, and we like inspiring them, and not only inspiring them, but getting them to understand how they can develop these careers in these cool fields of science. And of course, as you know, one of the challenges is to get people to understand kind of the coolness and excitement of math. And so the way you just said that, clearly you think it's pretty neat. And so as you were as you were coming up through school here in Georgia, as you were exploring your astrophysics at UGA, what kind of math did you have to skills did you have to develop, and I assume you have to continue to develop those.
Yeah, definitely. Just straight out of a classroom, calculus is really important. And I think, the basics like algebra, trigonometry, I think a lot of kids ask, when am I ever going to use this? And perhaps, if you choose to be an artist, you might not have to. But I think even some artists, the graphics of what I just watched were absolutely incredible. So shout out to whoever did that. But I think math, the understanding the concepts in math of calculus and trig and other subjects is important, but so are problem solving skills. I think that's probably the number one thing that I've learned is problem solving skills. When I'm confronted with something that I don't know how to do, or maybe I've never even seen before, how do I approach it? What skills do I already know that I can apply to that? I think that's something that I learned in all of my math and physics classes that isn't necessarily math or physics, is problem solving skills.
That's well said. And I would point out, like you did, of the how important math is to artists, particularly who are using the current digital media to bring all this excitement to you. But even things like LIGO, things like look at gravitational waves, I'm sure people say, why is that important? And I think that what you were just saying is part of that, of the answer to that. And if you want to add anything to this, please do. But just in terms of of understanding, kind of understanding gravitational waves is sort of understanding the language of the universe, and understanding those interactions of particles and gravity and all of the electromagnetic spectrum with the forces in the universe ultimately lead to very unique technological applications here on Earth, from everything from things you think about with technology all the way to how an artist renders something on a computer screen. Yeah.
I totally agree.
I always joke that, I really want to meet sometime with all the bright scientists who are out there, all our colleagues. I really want to meet the actual people. I bet it's not many people who actually understand how all these electrons translate into getting these images to us. There are plenty of people that can code and get things where it produces them, but I bet there are only 2 or 3 people in the entire world who actually understand exactly how that is really being done.
Mm-hmm.
And quite frankly, I think some of your physics colleagues might even say that they don't even understand that. It's just they know that it does and we can use it. And so that's kind of at the background of understanding the universe, is how does that stuff actually work?
Mm-hmm.
So I have just a couple more questions here before we end we have our, kind of our formal hour here of our planetarium program before we check in and see what's happening up at Wallops. But we had a couple of questions last night from some of our Fernbank staff about the Spock mission and the CubeSat. And actually, our physicist was curious about, as you guys were developing the spacecraft, how much of the actual building of components and everything did you students do versus things that were off the shelf? And then also, if you can talk a little bit about both those things. I'm sure there were some things off the shelf and some things that you built, but then just, what was it like, integrating all of that together? And then I know there were a lot of computer experts involved in that final integration that's going to go into really making this thing fly. So can you talk about that a little bit?
Yeah. So I would say a lot of our components were off the shelf, and I'm sure my mech lead friend would have much more to say on this. But so I know for sure things like our antenna, our UHF antenna, and our S-band patch, so how we communicate or how we're going to communicate, those were off the shelf. So certain things like that. I believe most of the core avionics stack was off the shelf, if maybe not all of it. So so basically the onboard computer, how it's going to run, those were off the shelf. The main thing, the most important thing about Spock is Spock Eye, which is the hyperspectral or multispectral imager. So how we're going to get our images, how we're going to take those images. That was completely designed in-house by students, undergrads, which to me is incredible. So the most of it, and like certain things were designed specifically for Spock. So we had a custom solar panel, but we didn't build it. We said, our engineers said, hey, this is what we need. They sent it off to a company, we got it. But the Spock Eye was definitely the baby of a couple of students. They worked countless hours to get it right, to calibrate it, to test it. As for integrating everything together, that happened not this past summer, but the 2 summers ago. And I happened to be in the lab while they were integrating it, and it was long days, long nights. Sometimes they'd be in the lab till 4 a.m. Working on integrating it. It was hard work, but they did it. And I did get to test some harnesses that were being put into Spock. So I can say that even though I was on mission operations, I did touch flight hardware. So I touched something that's going into space, which I think is really cool. As for a lot of the computer science people, they worked really hard on the software that's going to help downlink the data from Spock. Some of it we got from a company, I can't remember which one. So they didn't write all of that, but a lot of the computer science people that I worked with helped with the ground station, because that was also something that we built at UGA, was a ground station, which was really cool. So working on the interface for that, and working on the collection of data and how we're going to do that, and scheduling of data collection, that was all computer science people as well.
Well, let's I know that I was telling you earlier, and I'll tell the audience, I still do in my research, I make use of the laboratories with the geology department at UGA quite often, and there's a parking lot that actually is right in between the geology building and the small satellite research lab, and so I can attest to because I'm off Fernbank during the day, and then I'm come to UGA late at night. There's never a time when there's not somebody in that parking lot, or that parking lot almost full of I'm sure your colleagues were in there busy working. You sort of peer over the windows and see them in there occasionally, hard at work, very late at night. So I'm very happy for all of you that this is coming to fruition here with hopefully a successful launch this evening. And we're going to I'm going to just make a little announcement here to our audience. Again, if we're here for our normal planetarium program, I thank you for being here this evening, and thank you for your patience, as apparently Facebook was doing some of their updating. We all know that, right? Everybody, they're all different formats and everything. So that affected a lot of the Facebook Live broadcast today, not just us. I was hoping we would avoid it, but we always can dump things off here to YouTube. And thank you for following us over here. Rather than trying to possibly face additional technological issues, we have a stable connection here, and I would prefer to stay with it. I am not going to make my colleague Jim endure any more of the evening than he is willing to. So at some point, I'm sure I will lose him. I don't know how long you can stay around, Megan, but you're welcome to, and or to go away and come back. I'm just going to tell everybody my plan is to keep this YouTube channel active. In just a moment, we're going to go ahead and we're going to do try a couple of things. We're going to check. I'm going to go away from this and try to share with you first NASA television, and we're going to check in and see where they're at. I think they're in some just ISS programming right now, with technical 8:45 set to go over to link with Northrop Grumman, the engineering firm, space flight engineering firm, in charge of the entire mission and the spacecraft, the Antares spacecraft, and so when they pick up their feed, that would be on NASA TV. But there's also a feed from the Wallops Flight Center, flight facility up in Virginia, and I want to check in with that. We might be able to go ahead and see what's going on there. But as we do that, again, if you have any questions at all, and we'll take just another minute or two here, and just ask that if you have any questions about astrophysics or the UGA's small satellite program, please pass those along through Jim, and we will get those to Megan. While we are waiting to see if you have any, I'm going to go ahead and switch over here to see if we can check in with our with NASA TV and Wallops. And give me just a moment until I have to type in a few things here. We'll go ahead. Take me just a few moments to get over to Wallops. All right, so we're going to I'm actually looking at the NASA TV screen myself. I'm going to go ahead and try to go to the Wallops stream and see what we have. And we will do that right now. This is where I get to do my impression of a NASA media relations broadcaster. Let's see if we can hop over there to Wallops. Looks like they're a little in the dark there, as they would be here on the East Coast. There we go. So you're looking there at the Antares rocket on the launch pad at Wallops. If you're not familiar with Wallops, it is an island just off the Atlantic coast of the Delmarva Peninsula, a short distance south of the Maryland border. And as I was pointing out to some of you watching last night, my research is in asteroid impacts, and it's fun to think about the space facility, the space flight facility, literally being inside a large impact crater. This is actually just underneath them is about the outer rim of the Chesapeake Bay impact structure that was formed 35.5 million years ago by the collision of about a 2 to 3 mile wide rock hitting our planet. And those of us here in Georgia have kind of a special connection to that impact because it produced globs of melt that would have been flying over our heads here in Atlanta and landed, probably landed here too, but certainly we know that they landed in South Georgia and in parts of East Texas, and they produced these glasses that today we call tektites, and in Georgia we call those Georgia tektites or Georgites. If I look carefully around here, I probably have one of those. I'll actually, as we're looking at Wallops, I'm going to come back. I'll stop sharing just for a moment. And I'll show everybody this. This is a Georgia tektite, and this is a little piece of glass that was made of soil that actually is part of the ground about half a kilometer or so underneath where that rock is sitting there. And if I take this light and shine it through, I know it's a little weird with the optics and all with these backgrounds and everything, but we'll see if we can do this. There we go. You notice how it's this beautiful green color, and past the light it has this incredible sort of olive green color to it. That was hot molten material at about over 2,000 degrees back 35.5 million years ago, flying over our heads right here. So I'm gonna just check in here with we had just passing along from Jim, just that he says Senor Gato on YouTube says, please tell Megan that you did a great job. So,
Thank you.
And we're going to go back to our view here of Wallops. And I'll let, if Megan would, I will let her talk a little bit about what happened last night. We got very close to a lot of excitement, and then hopes were sort of dashed there at the end. So can you tell us a little bit about what the mission went through last evening?
Yeah, so I believe it was about maybe 11 minutes before launch. We were told that there was a boat in, I think a potential impact area. And so they had to get them out. And then I think they went back on schedule 5 minutes after. Then about like 30 seconds or something, within like a minute when they were supposed to launch, we were told that there were very high impact winds and they had to scrub the launch, which is very disappointing. I've been waiting for this for a very long time. It was supposed to launch, I think originally it was supposed to launch like a year ago, and then it was moved to like December, and it kept moving back. So it was like, finally it's on a rocket, it's gonna go, and then it didn't happen. But it's happening tonight, so I'm very excited. In like an hour, that's exciting.
I'm going to attempt to actually change to a little bit more appropriate background here. Let's see if I can do that. There we go. This is the daytime view of the Wallops Flight Facility in Virginia. And I'll mention that the importance of timing with these launches is important is a great understatement. Some of you may remember back in the summer, we had this incredible milestone, historic launch of the SpaceX's Crew Dragon. What was their first, the first U.S. craft and first certainly the first commercial U.S. craft and the first U.S. craft of any kind since the last shuttle flight to take astronauts up into orbit and ultimately to the space station. This was a little bit of a special thing because it's largely an automated flight. So we have a fuller manned flight with men and women on it here coming up in the not too distant future, where it'll be more of a saying, hey, we're on a rocket, we're actually flying this thing. But it was an important historic mission. And if you were watching for that back in the early summer, you probably remember there was delay after delay after delay after delay. And every time there was a delay, it was like, well, let's wait till tomorrow. And you would push the time. You may have noticed that the time would go back about an hour. And the next day, it would just like, it was 4 o'clock one day, 3 o'clock the next, 2 o'clock the next, and it just kind of kept going that way. And some of you may wonder why. Well, gee, we have these launches to Mars. We have these launches. You remember the launches of the space shuttle for some of us. They used to go into these long holds. You say, T minus, 2 minutes and holding, and let's hold for 2 or 3 hours. Well, that only works if you are like the space shuttle and you're not really trying to hit a particular point out in space, or that works for going to Mars, at least for a little bit, because your launch window is on the scale of weeks, not days, or in the case of if you're trying to rendezvous with a space station that's in low orbit around Earth, your launch window is essentially nothing. It's either you launch or you don't. And I was surprised last night when I learned that there was a 5-minute window on these launches. That seems kind of an eternity for a lot of missions to the space station. But yeah, if we get down there to anything that holds the launch tonight, basically you can look at your watch and you start counting about 5 minutes. And if you hold anything over 4 minutes and 59 seconds, then you can wait till tomorrow or the next day. That was kind of an interesting thing last night, where they actually held at T minus 11, and they held for about 3 minutes and then continued. And it was looking pretty good, but they were right up against the launch window at was it 10:43 or so last night. And so basically you can go ahead and expect tonight it will either launch at 9:17 or it will launch at somewhere between 9:17 and 9:22, or we will be doing this again. But I think the weather is good. Hopefully all the range issues are settled, and Megan and her friends and colleagues can look forward to finally being able to either celebrate or at least breathe easy, right?
Yes.
I just in overall, about how long did the development of this mission take? I mean, I remember when that lab opened up, it seems like an eternity ago. And I know that that these missions can take a long time, and it sort of to me underscores when you talk about even larger scale missions, just the enormity of what that takes. So can you talk a little bit about, I know you came into it there, but just how long that development took?
Yeah, I think from the lab's creation to now is about 5 years. And I can't speak as well to Mochi in terms of their setbacks, but Spock faced a couple of setbacks, one of them being COVID, but just unforeseen things that we didn't know or couldn't control ourselves set it back. So I think that also tells you, like, just we did everything we were supposed to do. We did everything that we needed to, and there were still setbacks. And I think in general, I think CubeSats take less time to develop, but considering this was our very first one and no one at UGA had ever done anything like this before, I feel like we did a pretty good job getting it in 5 years. And I think it's also really cool that a lot of us who were there from almost the beginning or at the beginning get to see it to not even the end, but in its own beginning in its own right. Because this
Well,
is just the beginning of Spock's journey.
Yeah, I was talking to some colleagues in other states earlier today who have had some experience with NASA and the NASA Space Grant, who I know was a big part of getting your mission to fly here with the Georgia Space Grant. But and they were telling me a little bit about their own experiences, and I think 5 years is pretty much kind of a norm when you get these things going, and you sort of scale that up to the big NASA missions. Typically, those are anywhere from 10 to 20-year projects, and I think a lot of people don't realize that. I mean, these are incredible investments of time. Sometimes we talk the numbers in terms of the dollar figures for big missions kind of, they get out there and all, and people talk about those, but and sometimes my colleagues make a point of, well, that's such a tiny part of the overall budget and everything of the nation and all. But I think a part of that never gets said is that's spread over an enormous amount of time, and so in a way it makes it even a tinier bit of budgets, because it's not just like this year's budget or that year's budget, but it's over. These are yes, they're big investments, but they over a large period of time. But I think the other thing that gets lost in our discussions sometimes, and that's why one of the reasons I was awfully glad that you agreed to be with us tonight, is these are not about machines. These are about people. These are people of young to old, of all different kinds of interest and backgrounds, from the science, from the engineering, from the finances, from the art and media and advertising side, from the computer side, from everything, through the flight engineers, the range officers that are in charge tonight. I think and I can't remember, was it Fitzgerald? That is or Fitzpatrick, that is who she was talking last night, who was the range director for Wallops, and she made the point that there are, never mind all the effort that goes into constructing the payload as UGA did, but all of the and then constructing the Cygnus spacecraft, then constructing the rocket, all the engineers, scientists, everyone involved in that, from the very bottom to the very top of that chain. Then you get out to actually launch it, and there are between she said 200 to 300 people that are required on site just to make this go smoothly. And so by the time that you've gone through all of that, these are thousands and thousands and thousands of people and their families, and that are really investing in these projects. And I in the few interplanetary missions that I've had the privilege of being on with toward the tail end of Magellan, to Venus, and also the solid state imaging camera on Galileo to Jupiter, and also having technically, although I was worked more on ground impacts and not and less with the space the things out in space, but having a lot of friends who were a part of the even the Deep Impact mission and the L-Cross mission, Impact to the Moon. I mean, these are families. I mean, everybody in these missions is one gigantic family supporting each other, and you know, I know kind of little speech there for me, but I'm sure that was no different. As I watched the presentation from UGA last night, it was clear that is absolutely no different for you guys. I mean, you're a family that will probably never part, right?
Absolutely. I think it's maybe a testament to late nights and early mornings, but it's my time in the lab. Obviously, it was amazing to get to work on a satellite, but it was also amazing to work with the people that I did. You know, it was really fun and cool to be around people who were just as curious and motivated as I was. And I think a lot of my memories in the lab are from long nights, but they're also from like times we would go to Dairy Queen after we would go to the Athens Radio Club meetings. It was when we did a 24-hour test, and in the middle of it, while the machine was running, we all ate cookout. It was just fun stuff like that.
Yeah, and we're looking here at the Wallops Flight Center in Southern Virginia on the just off the Delmarva Peninsula. It looks like we are. I'm trying to see if I can find an actual countdown clock here. They have a different sort of clock there in the lower part of your screen, but we're watching here as we see the Antares rocket, the launch vehicle for the Cygnus spacecraft, and the Cygnus spacecraft will go up to the into orbit and then dock in on if all goes well tonight, we'll dock early Monday with the International Space Station. I would give everybody a heads up. I can do this now. If you want to see the space station, you have a few opportunities coming up here, including tonight. If we haven't already missed it, let me see. I have to go over to my little application here to try to find that. I know that we have a couple of brief opportunities actually in real time. This is the fun of live broadcast here. It is 8:26 Eastern Daylight Savings Time right now. If you have a very low view of the horizon, you might go out and look to the just east of north, between you're going to want to look if you've got a view off to the just from about true north to about 30 degrees or so to the east of north here in the Atlanta area. You can go outside in exactly 6 minutes and 50 seconds, and you will be able to see the International Space Station for about a minute. It actually will be pretty bright at a magnitude of about -1. So if you have a chance and it's clear where you are, run outside here and take a look, and you'll see that ISS go by. That is what will be being aimed at tonight. It won't go up and directly dock with it. It will go out into orbit and then sort of catch up with it by Monday, and then hopefully successfully it's dock, or as I think the official term that the flight engineers use is berth with the ISS, and then it'll take my understanding is it'll take a little bit of time for them to get that full spacecraft unloaded. And Megan, I know you've been following the mission and everything as part of the team, and you want to talk just a little bit about there's other payload on this craft tonight, right? Going up to the ISS, and there's some pretty neat things on there. Do you have any insights into some of the things that's on there with your small satellite?
I know there's some really cool stuff, but I do remember, I think the thing with most people talking about was the toilet or the astronaut. That's what's sticking in my memory.
Yeah, there's apparently if you didn't hear Megan there, there's a new toilet going up to the astronauts and cosmonauts, and I know last night they were talking about some of the food as well. This is the way the astronauts get their get their groceries, and this is so one of the reasons these flights, they're going to do everything they can to get off the ground because they're hungry astronauts up there. And but apparently they get some treats every once in a while. So there are some pralines, and the one I remember was the chocolate covered cranberries. So there's some, I have to look up where some of those astronauts are from, or it's there. They pralines and cranberries. It's like that's quite a just in two things, they're quite a variety of foods.
Mhm.
But yeah, again, just to let you know, if you again have a chance to run outside here and look to just to the north and northeast in 4 minutes here. So we're looking at about 8:34 to 8:35. You can see the space station go by. I'll go ahead and give you a little bit of a preview that we have. Let's see if we can. I will do my best here to see what's going on later. I know we've got opportunities over the next few evenings, which kind of gives you an idea of if you want to maximize or minimize the effort, which usually means minimizing fuel. To get up to the ISS, you want to be launching at a time when the orbits are sort of naturally where you are. So these are heading from the northwest to the southeast, generally over the southeastern U.S. So that's why this is being launched in the time frame it's being launched in. And the ISS actually will be visible Saturday night, tomorrow evening, at for a little bit higher in the sky at 9:22 for just a very brief period of time, but a little bit brighter. And then Sunday evening at 8:35 to 8:37 for a couple of minutes, and even higher in the sky. It will be very, very bright with a magnitude of -2.2. And that will be traveling from just slightly west of north over to the northeast. So if you have a chance to any of those the next few evenings to go out and look, it's an excellent time to view the station from the Atlanta area. And if you are still with us here, we are watching the cameras at the Wallops Flight Facility in Virginia. Watching the Antares launch vehicle, the Antares rocket, on the launch pad, and awaiting the formal countdown here to launch at approximately 9:17 this evening of the Cygnus spacecraft to the ISS, carrying, among other things, the University of Georgia's SPOC, small satellite CubeSat, designed to study the coast of Georgia. And Megan, if you don't mind repeating what you did earlier for anyone who may be joining us now, just what that SPOC instrument is designed to do. And if you want to just give us a little bit refresher background about how this mission came to be, we'd appreciate that as well.
Yeah. So I can start with how SPOC came. So there was a group of students at UGA who decided that they wanted to build a satellite. And at some point, they found out that some faculty in the geography building wanted some data that could only be gotten from a satellite. So they kind of got together and came up with 2 missions, Spock and Mochi. And Spock is going to take images across a wide range of spectral bands, I believe from about 430 nanometers to about 860 nanometers. And it is going to use those images to monitor coastal health and ocean productivity, specifically in Georgia, but also in other places along the coast. But Georgia is the main target for these images. And we're also hoping to take some just cool photos of Earth that we can say, hey, look what we did. But that's the main mission of Spock, is to monitor coastal health.
All right, so thank you very much. And we are at 8:34. So again, just to remind you, if you do have want to run outside, well, right now, the ISS is passing along from the north to the northeast here in the Atlanta area. Very low on the horizon, though, about 11 degrees off the horizon. By Sunday night, it'll be up to about 24 degrees, so you shouldn't have any trouble seeing it at all. And we're going to have a handoff from the Wallops facility that we were at a moment ago. Right now, you're live with Megan Arrighetti, one of the members of the Spock team who was with the University of Georgia and is now a graduate student in physics at the Georgia Tech. And then we're going to, we'll cut away back to Wallops in just a few moments, and then we will go over to, very briefly, the to NASA. We'll have NASA coverage, which will have some more information as we go. So I'm going to cut back to the, I think 8:45. We'll have the full NASA coverage, and we'll have commentary over the top of that. And we're going to cut back to Wallops right now. And again, we're looking at the Antares launch vehicle on the pad. I'm going to try to get an official countdown here so we can follow that. Let's see if we can get a Cygnus countdown here. And I'm looking at the Wallops, some information from Wallops right now, and just so the our audience can get an idea here before we hand off to the NASA TV coverage. So we are here at we're approaching just about let's see, we are at approaching 8:40 p.m. So if I can do the math right, that is about 37 minutes. 37 minutes prior to scheduled liftoff of the Antares with the Cygnus spacecraft. Everything seems nominal at this point. Some launch statistics that Wallops has given out for today is that the Cygnus spacecraft on board is carrying almost 8,000 pounds of supplies to the International Space Station. So what that's 4 tons. So imagine the carrying several elephants on there. It is the spacecraft is the Cygnus spacecraft, which sits on top of the Antares rocket, is 20 feet tall, and with a volume of 950 cubic feet. This is the 13th rocket launch of the Antares vehicle, and the 15th Cygnus launch, and the 3rd orbital launch from Wallops this year, and the 77th global orbital launch in this year of the pandemic. So this is a very busy facility. I know that the range director last evening during the program was talking about the just how busy Wallops is. Sometimes everybody gets focused in on Cape Canaveral Air Station and the Kennedy Space Center in Florida. Certainly the big marquee flights and a lot of smaller flights take place from there. But the Wallops facility is incredibly important for these types of resupply missions, as well as all sorts of NASA and commercial flights, as well as a lot of other flight support operations for both the U.S. government and allies, and commercial aviation as well. So we are at 8:41, and we are about 4 minutes from probably getting an official countdown from NASA. There's an update just now that the range is clear. Range is also clear, not just of craft, both boats and aircraft, but also the range has to be inspected for any danger, both from immediate contact and also wind direction, with regards of delivering some of the gases, some of the toxic fumes that do come from the spacecraft. Those you don't want blowing back over populated areas. If there were a failure or anomaly, as they say, of the spacecraft, you don't want the wind directions to be such that debris would be carried over populated areas. So all of these are fine details that are carefully analyzed by the range officers. And right now, all of that is green, and meaning nominal operation for launch. We are going to go over to now to we're just a few minutes away from being able to join. And we can switch back actually between the Wallops cameras and the formal public NASA feed here in just a moment. I'm going to go ahead and here with, as we approach that, but we'll go ahead and wait for our handoff to NASA television in just about 1 minute. If you are watching simultaneously, realize that on any media, realize there is typically about a 15-second delay between this feed and the rest of the universe out there. So perfect timing doesn't quite work in this new online virtual world that we have been living in now for several, 5, 6, 7 months now. So I think everyone's used to that. But we're just a few minutes being able to go over to hand off to NASA TV, and where we will get the audio in addition to the camera. We'll go to a live countdown, and hopefully everything will remain nominal throughout the remainder of the countdown and launch. And just as we do that, I'll remind everyone that we have a very narrow launch window. So once we're aiming at 9:17, look at your watches. If anything disrupts it, you can hold for 4 minutes and 59 seconds. And then you had better do something, because these launch windows to get into the right orbits to rendezvous with ISS are very short. So look at your watch, and if it look at 9:17 and 9:22, this craft has to go somewhere in there, or we will be doing this again. And I'm waiting here. We're okay. I think we can hand off now to NASA TV. I'm going to come back here to Megan just for a moment, and while we're here, I'm going to come back to, let's see, we're going to cut away here for a moment from Wallops, and we're going to go over to a public NASA feed, and we will turn the sound up on this, and see where we are in the launch this evening.
14 seconds p.m. Eastern Time at the start of a 5-minute launch window. The weather for tonight's launch just couldn't be better. It is absolutely pristine at Wallops Island, just a few clouds at 4,500 feet, winds out of the northwest at 4 knots, temperature of about 58 degrees Fahrenheit. Everything is green across the board, and there is the target for the Artemis program coming up for NASA, the moon, with sights set on that destination to land the first woman and the next man on the surface of the moon in 2024. Good evening from Mission Control in Houston and the International Space Station Flight Control Room here at the Johnson Space Center. Flight controllers here are watching over the station as they do 24/7, 365, tending to its systems and the 3 crew members comprising the Expedition 63 crew. We'll talk more about them in a moment. Back at the Wallops Flight Facility, Northrop Grumman engineers are monitoring the countdown at this hour from the Range Control Center. They will be in control of the 9-minute climb to orbit for the 2-stage Antares rocket from liftoff to the point when the Cygnus resupply craft separates from the vehicle's 2nd stage. They just completed a poll of all of the engineering positions just a moment or two ago. Everyone is go for launch. In Dulles, Virginia, another team of Northrop Grumman engineers are on duty as well, ready to take over the flight of Cygnus after spacecraft separation under the direction of Mission Director Zach Dwyer. They'll be following all of Cygnus's maneuvers during its 3-day trek to the International Space Station. Back here in Mission Control in Houston, the Orbit 3 team of flight controllers is on duty with the station crew members well into their sleep period for the night. As was the case last night, Flight Director T.J. Creamer is back in charge, presiding over the Orbit 3 team this evening.
358. Excuse me.
Cygnus's launch was originally scheduled for this past Tuesday night, but a forecast of inclement weather at Wallops for both Tuesday and Wednesday night pushed the initial launch attempt to last night. And with the weather finally cooperating last night, the countdown reached the 2-minute 40-second mark before the launch was scrubbed. We'll talk more about that in a moment. At the present time, we're sitting at T-minus 28 minutes and counting. There are no issues being worked by the launch control team at Wallops. As we mentioned last night, each launch of a Cygnus cargo craft carries with it a tradition for Northrop Grumman, the naming of the spacecraft after a noted space explorer who contributed to human space exploration. The Cygnus being launched tonight is named for NASA astronaut Kalpana Chawla, who twice flew into space, first on the STS-87 mission aboard the Space Shuttle Columbia in 1997, and then on the ill-fated STS-107 mission aboard Columbia in 2003, in which she and her 6 crewmates lost their lives during entry. Kalpana Chawla, the first NASA astronaut of Indian and South Asian descent, being honored on this mission of Cygnus to the International Space Station.
So Megan, can you hear me?
Yes, yes.
All right, so we're watching here the Cygnus spacecraft on top of the Antares rocket at the Wallops Flight Facility in Southern Virginia. This is Scott Harris, the planetary geologist with Fernbank Science Center here in Atlanta, Georgia, along with Megan Arrighetti from Georgia Tech. She is a graduate student in physics there and a former graduate in astrophysics from the University of Georgia, and was part of the flight operations team, our mission operations team for the Spock satellite that is part of the payload in the Cygnus this evening. And we're we've been glad to have you with us for the our entire program tonight. And just as we sit here with just a little under a little over 25 minutes to go before the scheduled launch at 9:17 Eastern time. With all the work that you put in on this on the satellite that is part of the payload, do you have any comments just about your feelings tonight as you watch this launch prepare to happen?
I would say it's a combination of excitement and nerves. I think my nerves are a little higher than they would be if I were still a student at UGA and still a member of the lab, because my work didn't really start for real until Spock was launched. I am really proud of the mission operations team that they're doing a great job. And they're going to be wonderful mission operators collecting all the data. But I was always told that mission operations doesn't fully begin until Spock is orbiting. So I think this is both a beginning and an end to this, end to all the work, but a beginning to really cool data and actual that is Spock.
Yeah, I can imagine that all of you and all of your colleagues and friends who put in time working toward this moment. I am sure you were incredibly excited last night. I'm sure the excitement is no less tonight, but I would also imagine there's a slight degree of realism that set in after last night when you finally go through one of those launches that almost was. I assume that there's a little bit of a different feeling tonight, just a little bit more of a I don't know if calmness is the right word, but maybe the nerves off just a little bit, just sort of an understanding that, yeah, this might have a problem, but as you were telling me earlier, it's eventually going to go.
Yes. I would definitely all of that is true. That is true.
So let's see, we're at it's interesting, they don't have a formal countdown clock up. They've got it going the the other way.
Mhm.
So we're looking here at just coming up on just at 8:53. And for scheduled 9:17 liftoff. So if I can do math, that is 24 minutes from now. And these, unfortunately, we are just a bit too far south to actually see these launches from the Wallops facility. If you're in off the coast of even the mid coast of North Carolina, you actually have the opportunity to see these sometimes. Certainly, if you're closer into the Norfolk, Virginia area and Washington, even Washington D.C., you have an opportunity to see these as well. But we're going to go back here and listen to commentary by the NASA Media Relations Office. And we'll also have periodic interruptions by the range officers at Wallops. And we'll add commentary from here as we proceed.
Copy, not required.
On board the International Space Station, Cassidy Wagner and Russian cosmonaut Anatoly Ivanishin are asleep at this hour, less than 3 weeks away from the end of their 6.5-month mission on the orbital outpost. They are scheduled to return to Earth on the evening of October 21st U.S. time, which will be the morning of October 22nd on the steppe of Kazakhstan, for a parachute-assisted landing in their Soyuz MS-16 spacecraft. That will come 8 days after the arrival of the next trio of residents to the International Space Station, NASA astronaut Kate Rubins, Sergei Ryzhikov, and Sergei Kud-Sverchkov of Roscosmos, who are in final training right now at the Baikonur Cosmodrome in Kazakhstan for their launch on October 14th in the Soyuz MS-17 spacecraft. Inside 21 minutes until launch, everything continues to proceed on track and on time for a liftoff at 8:16 and 14 seconds p.m. Eastern Time.
We'll check 379.
The ascent profile for Antares and Cygnus following liftoff calls for main engine cutoff on the first stage of the Antares rocket about 3 minutes and 18 seconds after launch, followed 6 seconds later by the separation of the first stage. Some 30 seconds later, the fairing, which encapsulates the Cygnus resupply vehicle, will also separate, exposing Cygnus during the uphill ride to its preliminary orbit. Stage 2 ignition on the Antares rocket is scheduled at about the 4-minute, 7-second mark into the flight. It will burn for 2 minutes and 44 seconds until Stage 2 burnout occurs, putting Cygnus into its initial orbit, with the Cygnus vehicle itself separating from the second stage of Antares at about the 9-minute, 9-second mark into the flight. The Ultraflex solar arrays on Cygnus are scheduled to be deployed about 2 hours and 8 minutes into the mission. We will not be on the air live during that activity. It's about a 30-minute procedure. We will, however, provide updates on the web on nasa.gov and the station blog site when solar array deploy is completed later this evening. If everything goes as planned, Cygnus again will arrive in the wee hours Monday morning at the International Space Station, arriving along the intersection called the R-bar, the radial vector, which is an imaginary line drawn between the International Space Station and the Earth. The Cygnus will arrive about 400 feet directly below the station and inchworm its way up to the point where Cassidy will use the robotic arm to reach out and grapple the resupply craft. The capture of Cygnus is scheduled right now at 4:20 a.m. Central Time, 5:20 a.m. Eastern Time on Monday morning.
So in real time, we actually are at T minus 1749.
And Ops 2 LC, countdown.
There's about a 30-second delay actually between
Good, LC.
the
Yeah,
feed
just be
and
advised,
real
step
time,
386
so
will be
that is
required
not
for today's
a
op.
delay with us. That's a delay
Copy
with
that.
the NASA feed.
And LC, this is prop lead. Actual F1N level is 10 of 10.
Copy 10 of 10, 381, Core 1. Provide status on F1N level.
LC Core 1, countdown 1, standby.
As we approach the 17-minute mark into the countdown, propellant loading is complete. You see the venting at the interstage area of the two-stage Antares rocket. Everything continues to be green across the board at Wallops. The weather is perfect. Everything all set for Antares to begin its flight to deliver the Cygnus resupply vehicle to its preliminary orbit.
So as you see there, they're venting off excess propellant so that the
And CMDLC, countdown 1.
LC Core 1, countdown 1.
Go ahead, Core 1.
Fuel level adjustment is not required.
Copy, not required. We'll go ahead and check 382. And prop 2, step 383, configure OCCS for no adjustment to fuel level.
anytime you see a rocket fired, you'll always
CMDLC, countdown 1.
you will always see the
LC the CMD.
you'll always see the venting from either different stages or from the base of the rocket as excess propellant is vented away from the spacecraft. The last thing you want to do is have any propellants that are in the way of the first stage when it fires. That's a good way to get a nice explosion. But here we are just approaching T minus 15 minutes, and we're looking at the Cygnus spacecraft on top of the Antares launch vehicle, carrying a payload that includes the small Spock satellite that was developed by the Small Satellite Research Lab at the University of Georgia. We are joined by Megan Arrighetti, one of the team members from Spock, who is now a physics graduate student at Georgia Tech. And we are anxiously awaiting, along with everyone associated with all of the University of Georgia, for this first flight of the UGA spacecraft up to the International Space Station.
On the 20th.
Just passed through T minus 15 minutes. We'll be coming up on our polling for our final count, proceeding with our final countdown in just about 2 minutes.
On the 20th anniversary of the launch of Expedition 1, Bill Shepard, Yuri Gudzenko, and Sergei Krikalev, on October 31st, the Crew 1 mission is scheduled to launch aboard a SpaceX Falcon 9 rocket. The Resilience Crew Dragon spacecraft with Mike Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi on board, scheduled to arrive at the International Space Station on November 1st. T-minus 14 minutes and counting.
So as you heard the range officer say there, T-minus 14 minutes and counting, and we are approaching T-minus 11, where there was a hold last night due to a boat in the range. The range has to be cleared of all peoples and vehicles, both on the water off the coast, as well as any aircraft aloft that are not in NASA control. So hopefully there will not be any delays of that nature this evening. Again, if there are delays, and this becomes a very critical moment in this next phase of the countdown, because when you're trying to go to the International Space Station, these are basically launch or no launch conditions. There aren't huge holds. There's a 5-minute launch window, which I still find extraordinary, given most of the ISS launches that occur. But it is still a very narrow window. And so again, you can look at your watch now at 9:17 and 9:22, and it will be somewhere between there or not at all. And along with all of us here in Georgia, particularly those associated with the University of Georgia, and particularly the team that Megan, our guest, was part of and one of the leaders of, this becomes a very tense 10 minutes or so here. So you want to have a few more comments here, Megan, as we get to that about T minus 12-minute mark here, waiting the launch.
Yeah, sure. We talked a little, but it's a lot of feelings, nervousness. It's this completion that we built a satellite and the orbit the Earth. Not immediately, but this is the first thing. It's just generally. I think it's a sense of accomplishment that a group of undergraduate students, now a lot of us turned graduates, a group of undergraduate students who had this idea, built a satellite, and we were the first people at UGA to do that. So I think for Caleb, one of the founders of the lab, that it really well is that if someone were to come to UGA and say, hey, who knows about satellites to a group of 20-year-olds. And I just think that's really
Dogs in space.
yes.
Reminds me of a way before your time with there was this Muppet Show thing with that had a segment called Pigs in Space. So tonight, no pigs in space, just dogs headed to space. And I know there was some discussion last evening by the program administrator, program manager, who is a UGA alum as well, about the where we have to go from here, and the ultimate goal, we have to get UGA to Mars.
Yes.
All right, so we're approaching the 10-minute mark. We're going to go back to the both the NASA public media officer and the range officer at Wallops.
And T minus 10 minutes.
No issues being worked in the Range Control Center at Wallops Island, Virginia, or at Dulles, Virginia, where the Cygnus spacecraft team for Northrop Grumman monitoring Cygnus's systems ready to take over at the time of spacecraft separation just over 9 minutes after launch.
And Ops 1, Step 391, enable ACS VDMs.
LC Ops 1, ACS VDMs internal power on.
ACS VDMs enabled, voltage nominal, and commands cleared.
Copy that. Elect 1, check 391, check 392. And launch team be advised, Step 393 will not be required for today's operation.
Once Cygnus arrives at the International Space Station in the wee hours Monday morning and is grappled and then installed and bolted into place, a series of leak checks at the berthing interface between Cygnus and the Unity module will be conducted by NASA astronaut and station commander Chris Cassidy, making sure that we have a tight seal between the Cygnus and the station before he begins the process of opening the hatch to Cygnus and the start of the unloading of the most time-critical experiments and supplies that are being brought up on the Cygnus resupply vehicle.
Copy, site control, check step 394.
Coming up on the 7.5-minute mark until launch. Passing through 7 minutes until launch.
T-minus 7 minutes. And op 2, you go to initialize ground ordnance power supplies.
LC op 2, ground ordnance power supplies initialized.
LC,
Ground ordnance power supplies nominal.
LC prop lead, APSO activation verified.
Copy all their prop lead, ops 2, elect 1, check 395, 396, and 397.
T-minus 6 minutes and counting. Northrop Grumman preparing to provide Friday night lights down the eastern seaboard. Everything is go for launch.
LC site control, aft A ECS transfer to GN.
Well, most of our audience in
Roger that,
Georgia,
site control,
if you
check
happen
step
to be
398.
in the northern parts of North Carolina,
And launch to be
Boston.
advised, step 399, not required for today's operation.
this can put on quite a light show.
Coming up on the T-minus 5-minute mark.
T-minus 5 minutes, ops 1, transfer avionics to internal power.
LC Ops 1, avionics internal power on. Stand by for command completion. LC Ops 1, external power off.
Internal power is nominal.
Roger that, elect 1, ops 1, open STS umbiloop.
LC Ops 1, FTS umbiloop open and green.
LC elect 2, FTLU and FTS receiver indications are nominal.
Copy, elect 2. Ops 1, you go to send, all arm command.
LC Ops 1, all arm command sent.
SNAs, ODMs, all arm.
NASA TD, report range status.
LCTD, range is green.
T-minus 4 minutes and counting. Everything in order. No issues being worked at the Range Control Center at Wallops.
Everything is looking good here for a imminent launch. I'll just make a quick comment as we approach launch that if you missed it earlier, the spacecraft is named, the Cygnus spacecraft aboard the Antares is named the Capanachala for the Columbia astronaut, 2 Columbia missions. That was the first astronaut of Indian descent, who unfortunately gave her life for our space program in 2003 with the Columbia reentry disaster. So as we've been reminded of that through the evening, when you have been around the space exploration as long as I have had the privilege to be, that actually gives you a few little extra chills as you listen to it. We have this very important mission here, resupplying the crew members of the International Space Station. But as we approach the launch, just a reminder, the reason we are here tonight, the reason we have our special guest, Megan, with us this evening, is because of the incredible work that she, along with her colleagues, her undergraduate colleagues, did at the University of Georgia Small Satellite Research Lab, preparing the Spock satellite that is part of the payload. And it hopefully here shortly will be on its way to the International Space Station for deployment from the space station a little bit later this year in November. When deployed, it will take pictures of the Earth's oceans, including the Georgia seacoast, and help us understand more about how both the biology and the geologic systems work along those areas of our coast. So we're going to go back here with just under 2 minutes to the NASA public media officer and the range officer at Wallops Flight Facility in Southern Virginia. And we get ready to send dogs to space.
90 seconds until launch.
T-minus 1 minute, 30 seconds.
At this point, these are automated systems that come into play. If there's an abort, the systems will automatically abort. There will not be calls by the range officers. As is last night, we got down inside of this time and there was an automatic abort. So we hope that is avoided this evening at T-minus 1 minute and counting.
T-minus 1 minute.
Well into the terminal count. T-minus 50 seconds and counting.
T-minus 30 seconds. Mark.
T-minus 15 seconds.
T-minus 10.
6,
5, 4, 3, 2, 1. We have engine ignition.
Engine start and liftoff. The SS Kalpana Chawla takes flight, sights set on the International Space Station. Pitch and roll programmer in.
Vehicle systems are nominal. Engines at 100%.
And I'm going to come over here to Megan just so we see your smile and expression here as this rises into the sky. And we'll go back here just on the to continue the liftoff.
Engines are steady and nominal. 100%. Altitude 20,000 feet.
1 minute into the flight, everything looking good on Antares.
Passing through max Q. Attitude nominal. Engines at 100%.
Antares passing through the area of maximum dynamic pressure.
50,000 feet.
Attitude nominal. All vehicle subsystems are nominal.
Coming up on the 2-minute mark into the flight, everything looking good.
Just passing 100,000 feet. Attitude nominal. Vehicle subsystems nominal.
As we watch this, Megan, I'm struck by the, it felt like it takes forever to get to that 0 countdown. And then all of a sudden they start saying a minute into flight, 2 minutes into flight. It's like, wait, what?
Yeah,
Did that go by?
I would agree with that. It does not feel like it's been a minute.
Attitude nominal. Vehicle subsystems nominal.
It's nerve-wracking.
From the range control center at Wallops.
Going up there so fast. It had to go.
Throttle down is the precursor to main engine cutoff for the first stage. Coming up on the 3-minute mark into the flight.
Engines at 55% thrust.
Standing by for main engine cutoff on the first stage.
Main engine cutoff. Stage 1 separation. Attitude nominal.
Stage 1 separation confirmed from the range control center. And Terry's flying straight and true.
Terry's in coast phase until proper conditions for fairing separation and stage 2 ignition are achieved.
Fairing separation confirmed. Cygnus now exposed to the atmosphere as it continues its trek uphill to its preliminary orbit.
Stage 2 ignition.
This will be about a 2-minute 44-second burn of the second stage engine.
And we will follow through that burn and just as telemetry comes in, and then we probably will say goodnight here because at this point the spacecraft is on its way. As this burn concludes, it will be in its primary orbit to eventually rendezvous with the space station early Monday morning.
Attitude nominal. Vehicle subsystems nominal. 140 kilometers.
Coming up on the 5-minute mark into the flight.
All systems continue nominal. Altitude 150 kilometers.
As you're watching there, you have real-time telemetry. I would pay most attention to the velocity. As long as that velocity is continuing to climb under the acceleration of the burn, that's what you want. Any deviation from that, from the telemetry from the spacecraft, would be quote an anomaly and would be bad. But everything seems to be looking good.
All systems nominal.
The second stage burnout is scheduled at about the 6-minute 51-second mark into the flight.
Altitude 170 kilometers, roughly 1 minute to stage 2 burnout.
About 30 seconds to burn out and establishment of the primary orbit.
Altitude 184 kilometers, all systems nominal, roughly 30 seconds to stage 2 burnout.
Six minutes, 40 seconds into the flight, standing by for stage 2 burnout.
Stage 2 tail off. Stage 2 burnout.
And Cygnus has reached the preliminary orbital insertion.
Antares will coast for roughly 100 seconds prior to payload separation.
And as you heard, the next major event will be Cygnus's separation from the second stage.
Attitude nominal.
Well, we'll hold for that. Just
Cygnus has begun its journey to reach the International Space Station early Monday morning.
All vehicle subsystems nominal.
again, notice the telemetry, the real-time telemetry from the spacecraft there on the right. You notice the velocity now is stable.
Altitude 191 kilometers, roughly 1 minute to payload separation.
Liftoff occurred right on the dime at 8:16 and 14 seconds p.m. Central Time, 9:16:14 p.m. Eastern Time. The International Space Station and its 3 crew members who are asleep at this hour approaching the southwest coast of Australia.
Altitude remains 192 kilometers, roughly 30 seconds to payload separation. All systems nominal.
At the time of Cygnus's separation from the second stage, the operations will move to Dulles, Virginia, and the Cygnus Flight Control Room under the direction of Mission Director Zach Dwyer.
Notice that we're the spacecraft's traveling at about 7.5 kilometers per second, so that's fast.
Cygnus separation.
Spacecraft separation confirmed. The SS Kalpana Chawla well on its way to the International Space Station.
CCAM initiated. Attitude nominal. LC ace out.
All right, and I think there we are for the evening, and we're going to come back here to our guest this evening with Megan Arrighetti, and congratulations, Megan, on a successful launch of your payload with your spacecraft aboard the Cygnus, and look forward to you guys deploying deploying that satellite here in a month or so.
Yes, thank you.
So just any final remarks here on your behalf of yourself or behalf of your team?
I think I can speak for all of us in that we're really excited. And I think I'm really excited personally to see how far the lab can go. I think we left it in wonderful hands, and I know that they're going to do great things. So I can't wait to watch them do those things.
All right. Well, thank you so much for being with us. Congratulations again to all of you. Go Dogs! And now that you're over at Georgia Tech, in the enemy camp, then please, we love our Georgia Tech colleagues, and please come over and when we get back to normal, and feel free to visit us at the Science Center and be a part of what we do over there. And again, just a wonderful evening here with a successful launch. And thank everyone who's out there who has watched us. If you're watching this in the recorded fashion and have any questions about anything in the show, from the universe to spacecraft launches, then please feel free to get a hold of me. You can contact me through the center, or email me at scott.harris@fernbank.edu. Just a reminder, tomorrow at 1 o'clock, Saturday afternoon, October 3rd, we will have our regular Planetarium show, where I will fly you through the solar system, focusing on the moons of Saturn. And we also have the Association of Association of Lunar and Planetary Observers are having a online conference this weekend between about 1 o'clock and 5 p.m. Eastern Time tomorrow. If you look them up on, just look up again, the Association of Lunar and Planetary Observers. They will be broadcasting by YouTube or hopefully Facebook Live if it's back working tomorrow. I will say that if we are on tomorrow with our planetarium show, we'll be on whatever's that working. But if you do want to look at some of the people who observe the moon and Mars, both professionals and professionals and amateur astronomers, then please join them tomorrow afternoon. I will be giving a talk at 3:20 Eastern time on their broadcast about the threat of small asteroids and comets to our planet. So if you have an opportunity to stop by, I would love to have you watch that. Again, thank you for all for being with us this evening and bearing with us through the technical difficulties at the beginning. Again, thank you, Megan, and congratulations. And we hope to see you at a minimum next Friday for our regular planetarium show. And good night. Have a wonderful weekend. Everyone stay safe and healthy. And we're out.